Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions. And in this class we are going to find out the domain of this function, which is f of x is equal to square root of 9x square minus 4 divided by mod of x plus 1. So we have already solved a number of problems related to finding out the domain of functions. And in this class, we'll find out the domain of this function, which is the quotient of the square root function and the absolute value function. Right. So here we have the quotient of two functions. So let us take the function which appears in the numerator as say g of x, right? And the function which appears in the denominator, let us take it h of x. So g of x is square root of 9x square minus 4, and h of x is equal to mod of x plus 1, right? So to find out the domain of this function f of x, we have to search for those values of x which are common to both the functions, that is g of x and h of x, right? So by domain of a function, we mean that all the valid values of x, right? So we have to find all the values of x which makes this function defined, right? So now let us consider the function g of x, right? And here we have square root of 9x square minus 4. So the domain of g of x can be given by all values of x, which makes 9x square minus 4 greater than or equal to 0, right? Because this expression, that is 9x square minus 4, should be greater than or equal to 0, because then only the function g of x is defined, right? So if this function 9x square minus 4 it becomes negative for some values of x, then g of x cannot be defined in the set of real numbers, right? So for g of x to be defined in the set of real numbers, 9x square minus 4 must be greater than 0. Greater than 0 implies that 9x square minus 4 should be positive, or it may be equal to 0. So now let us solve this inequality. So to solve this inequality, what we will do, we'll take minus 4 to the right hand side. So we have 9x square greater than or equal to 4. And now dividing both sides by 9, we have x square greater than or equal to 4 over 9, right? And we can now write x square greater than or equal to 2 by 3 whole square. So 4 over 9 can be expressed as 2 over 3 square, right? So now here we have an important type of inequality that is of this form, that is x square greater than or equal to say a square. So in this case our a is 2 over 3. So now the solution of this type of inequality can directly be written. So when x square is greater than or equal to a square, then x belongs to this interval, that is from minus infinity to minus a. And here minus a, that is this point is also included, and union, and then we have a to infinity, right? So in this case, if we utilize this result, then the solution of this inequality can be written as x belonging to the interval, that is minus infinity to minus 2 by 3, and then union, and here we have 2 over 3, that is positive 2 over 3, to infinity, right? So the domain of this function g of x is given by the union of these two intervals, right? So let us express or represent this domain on the real number line. So here we have the real number line, and now here we can write 0, here we have -1, and here we have +1, right? So minus 2 by 3, it lies somewhere here, that is close to 0. So here we have minus 2 by 3, right? So here we can write minus 2 by 3, and uh, plus 2 by 3, it lies towards the right of 0. So here we have 2 by 3, that is plus 2 by 3. So now our values of x goes from minus infinity to this point, that is minus 2 by 3. So here we can make this point dark to include it. So minus 2 by 3, here we have minus 2 by 3, and then from 2 by 3 to infinity. So here we have 2 by plus 2 by 3, and then we'll go up to infinity, right? So here we have plus 2 by 3. So this region is excluded, right? So from minus 2 by 3 to 2 by 3, the region is excluded, because all the values of x which belongs to this interval, that is from minus 2 by 3 to plus 2 by 3, the function g of x is not defined. So now let us consider this function h of x, right? So the important thing about this function mod of x plus 1 is that this function appears in the denominator of this function f of x, right? So we can straight away conclude that h of x is not defined for x is equal to minus 1, right? Because when x is equal to minus 1, then the denominator becomes 0, and f of x is not defined, right? So the domain of h of x is given by all real numbers excluding this number, that is minus 1. So our function h of x, which is mod of x plus 1, this function takes all the real numbers except minus 1, because when we take x is equal to minus 1, then the denominator becomes 0, and as such the function f of x is not defined, right? So let us express or let us represent this domain or this interval on the real number line. So r minus minus 1 is represented like this. So we have all the values in this interval excluding minus 1. So for representing the exclusion of minus 1, let us draw a circle here, right? And then we have all the values running from minus 1 to infinity, right? So this interval, that is from minus infinity to minus 1, then from minus 1 to infinity. So we can also represent this domain as minus infinity to minus 1 and union. Then we have minus 1 to plus infinity. And remember here this point, that is minus 1, is not included. So now to get the domain of f of x, what we have to do, we have to merge this domain and this domain, right? So let us call the domain of g of x as d1, and the domain of this function h of x as d2, right? So the domain of the function f of x is denoted by df, and df is given by the intersection of d1 and d2, right? So the intersection represents that we have to find out, or we have to consider only the common values of x satisfying both the functions g of x and h of x simultaneously, right? So let us identify the intersection of D1 and D2 from this diagram, right? Now see, from minus, first we'll go from minus infinity to minus 1, right? Because see, this region is common to both the domains, right? So first we'll write minus infinity to minus 1, and then we'll write the region that is from minus 1. Here we have minus 1, and here we have minus 2 by 3, right? So this region is also common, and excluding minus 1, so here we'll write minus 1, and then here we have minus 2 by 3. So minus 2 by 3 can be included, right? So we'll exclude minus 1. That's why we are writing here the open interval. So we have minus 2 by 3, and here we'll draw the closed interval. So the first region is from minus infinity to minus 1 and excluding minus 1, and then from minus 1 to minus 2 by 3, including minus 2 by 3, and then the last region is from 2 by 3, that is plus 2 by 3, right? So here we'll include plus 2 by 3 to infinity, right? So here we have plus 2 by 3 to infinity. So viewers, the final domain of this function f of x is given by the union of these three intervals, right? And remember here this region that is from minus 2 by 3 to 2 by 3 is excluded, and obviously minus 1 is also excluded, right? So the domain of this function f of x is given by minus infinity to minus 1 union, then we have minus 1 to minus 2 by 3 union plus 2 by 3 to infinity. This point minus 1 is excluded, and minus 2 by 3 and 2 by 3 are included.